Rolling. This is a Facebook interview. I'm in a very, very cool place. So cool, so unique that very few outsiders are allowed here. I am about half a kilometer below the earth. And where? Inside a uranium mine. And what the hell am I doing in a uranium mine 555 meters below the earth? I'm here because India has set up what is the deepest underground laboratory in the 21st century. A laboratory which is going to look for a thing called dark matter. Now, what is dark matter? Dark matter, why should we worry about dark matter? The entire universe, whatever we see, is composed of what is called visible matter. And that constitutes just about 5%. So all the sun, the galaxies, the earth, the moon, you, me, everybody, Dr. Naba Mondal, my cameraman Shankar Ghosh, all of us constitute just about 5% of the entire matter. There's another 24% which is dark matter. And that dark matter is unknown. Nobody really knows about it. And there is a large amount called dark energy, more than 75%, which people really have no clue about. So India is now joining a search for dark matter. Now, why do you need to come underground, deep underground? People who go underground are usually people who have committed some sin, who have committed some crime, and they are hiding from the police. So why are Indian scientists coming underground? They are coming underground because some of the instruments need to be shielded from some of the most oppressive and deeply penetrating particles called muons and cosmic rays. So I am standing in a very cool place, very unique place called the Jadugoda Underground Science Laboratory, inaugurated recently, and a place which will take India into new heights. I have with me Dr. Satyajit Saha, who's the lead for this experiment on dark matter laboratory. What is dark matter and why should anybody, especially youngsters, worry about dark matter? We only know about the dark web.
Okay, dark matter is something which is actually part of the universe. See, when universe was started in the with a big bang, then it was before Big Bang, the entire universe was filled with energy. Then at the point of Big Bang, matter started to form. All these, initial particles were formed, and then gradually bigger particles were formed. And so then the universe has started accumulating mass, creating masses are created from energy. Now, out of those masses, if we look at the present scenario, that universe has come to a very cold space because the universe has formed quite a long time back, and once it's formed, the present universe, if you look at the composition from various astronomical observations, it is found that the universe actually contains about 5% of normal matter which is available. Now, this dark matter is almost like 25% of the universe. Now, this 25% dark matter, the curious thing about it is that it doesn't interact with the normal matter particle. It can only interact with the help of gravity or by giving a very tiny kick to the normal matter.
So how do we know that it exists? If you have not detected it, if you have not seen it, how do you know it exists? Maybe it's just your imagination and you're wasting the country's money by coming down here.
Well, actually, this, the astronomical observations that has been conducted so far, there are several evidences from the astronomical observations, including qualitative as well as quantitative evidences, which actually gave us this inference that there is dark matter, because you can feel that, particularly from these galaxy rotation curves. If you determine the rotation curves of the galaxy, you can see that the galaxy is actually, particularly the edges of the galaxies maintain a larger speed than what is expected if you have a concentrated masses which are actually observable. Like when you observe the visible masses, you can actually observe them with the help of this electromagnetic.
So you're saying this dark matter provides a kind of a gravitational force?
Yes, dark matter will definitely has a gravity. It's a gravitating object. Now it will be interacting with the normal matter only through the gravitational interaction.
So would it be okay if I called it kind of a celestial glue which keeps our solar system and the galaxies together? Would that be a good characterization, that it's an invisible celestial glue?
You can say that. It is, to some extent, it is all pervading. But the point is that the distribution, one can calculate what will be or estimate from from different astronomical models that what will be the composition, what will be the density of this kind of dark matter, and there is a fixed number that is known. But the point is that this density is not uniform all through. So there are clumps and clusters in the galaxy where these dark matters are concentrated. Okay, so similarly, within our Milky Way, that is the galaxy to which we belong, there can be dark matter densities which can have some variations. Okay,
so why do you need to come down? What are you hiding from? Have you done some crime by your coming down half a kilometer below and hiding in this small cavern?
Okay, so hiding is it. Okay, so whenever we want to detect these the existence, or rather look at the dark matter and try to determine them, though they are very feebly interacting, we should not have any interference from the other kinds of particles, because see, we are always at the surface we are always bombarded by cosmic particles, and that cosmic particles actually heat and pass through. They are very deeply penetrating. They will pass through your body and pass through the earth, and even at 555 meter level you will find that there are these cosmic ray particles reaching there. They have sufficient energy to penetrate deeper into the earth. Okay, so here what we do is by having such a rock overburden, that we call this rock overburden as the mass of the earth which is above where we are standing, so that itself will be shielding the cosmic particles from earth. So here we can at such a depth we can actually measure what will be the amount of cosmic particles, particularly the cosmic muons, which are the most abundant cosmic particles at the surface of the earth, how much of it is getting reduced. Okay.
So you're essentially cutting out some particles which get absorbed in what would be 555 meters above me, the rock level. Right. Is that correct?
Yeah. It will be reducing their number. So it will be stopping some of them within the rock, and that factor can be anywhere from a few thousand, about a few thousand for a site like this, compared to what we get at the surface.
We also have Dr. Susnata. Susnata, you've done a PhD on dark matter.
Yes.
When it can't be found, can't be seen, what did you do in your PhD?
But I think this is also one result that this is not, we cannot say that you cannot find. So because in the result we make some plot of what will be the range of dark matter particle and what would be the range of its cross section. So that idea we can get from our result. We cannot say that we find nothing from that. So it is something positive to us that this range will be up to that range, and then cross section means it can when there is some probability of interacting with other particles. So I cannot say that this is very interesting. Yeah.
Looking at this laboratory which is there,
Yeah.
made of stone so far below, Does it excite you? Does it worry you?
Yeah, obviously, because I have started my PhD under Professor Piyushpani Bhattacharya, and at this time I was working with some other international collaboration. There is Professor Mala Das in her lab. I am doing the experiment, but I have not gone that underground lab previously. But I go some University of Canada, Montreal, to learn how I can analyze the data. But this is the first time I am coming to this lab, and it is in India, and this is very exciting.
You're not afraid of coming here? This is a uranium mine, and
I am not afraid.
did your family say don't go?
No, actually, this. If it is the beginning of my PhD, they may have told that you can't go, but now they know that it is not any problem.
Now they know that you will chase dark matter all your life?
Yeah, maybe.
And is that something which excites you, that all your life you may look for dark matter and probably not find it because it has not been found in last so many decades?
No, yeah, it is exciting to spend my whole life in dark matter experiment. I have no problem.
So from somebody who's wanting to spend her lifetime looking at dark matter, I have also with me Dr. Naba Mondal. Dr. Naba Mondal is one of India's foremost underground scientists, I can say. He has spent years underground. And trust me, there is no FIR against him. The police is not chasing him. But he spent many decades in a laboratory in India called the Kolar Gold Field laboratory, which was at the depth of 2.3 kilometers. This is only about half a kilometer deep. So, Dr. Naba, you spent so much time in a laboratory 2.3 kilometers deep. What did you find there, and why should India continue to have an underground laboratory?
Well, when I went to Kolar Gold Field, it already has a big, list of achievements and its list. For example, that was the place where the atmospheric neutrinos was first detected in 1965. Of course, I didn't join that time, and my predecessors did that experiment. And we did also quite a few interesting experiments at Kolar Gold Field. For example, first ever proton decay experiment anywhere in the world was first started at Kolar Gold Field. And it was really exciting that time we are building particle detectors which can compete with the whole world actually, because there is a big push for making such detectors in United States, in Europe, in Japan. And our detector, the KGA proton decay experiment, was the first detector that came up and became operational. So that was.
Is there some finding which can be credited to the Kolar Gold Field laboratory?
Yeah. So I told you this one. The first thing is that first ever cosmic ray neutrino was detected at Kolar Gold Field in 1965.
So why should that excite anybody who's, say, sitting in Jhumri Talaiya or sitting in Kanyakumari?
Well, it is actually, so if you say that one, yes, it is true that what is due for common man? Why should common man will be excited by doing that? But you take us as a whole human race, as a big family, and we are making progress because we are thinking, we are asking questions, and these discoveries are part of this process of this thinking, of our looking forward, of finding new ways and how things work to explain the nature. So surely, if you can tell the people, in common language, they will equally get excited to know this result.
One of our viewers had asked me a question on Facebook saying, why did we let the Kolar Gold Field experiment die? Why did we not continue with it?
Absolutely true. It would have been really great to have the Kolar Gold Field, because this was the deepest mine. Even if operational today, it would have been the deepest mine in the world. So the question comes, I don't know whether you are familiar with the Kolar Gold Field. Kolar Gold Field is a network of tunnels, and it has been, they are extracting gold for hundreds years. And what happens there, the total network of tunnels interconnecting to each other is actually something like 1,200 kilometers underground. It is a network of tunnels. So when the gold was exhausted, and if you want to continue running that mine, there is an operational cost. And we did approach the government of India in late 80s and early 90s, requesting them that if they can fund for the operation of the mines for the sake of science. And government did try. They came and did some survey, and the cost became prohibitive just to run a science laboratory. So government told us.
What was the cost expected?
That was in around late 80s, and the cost was around 15 crores per year.
15 crores today doesn't sound very large.
Yes, but remember, this was late 80s and early 90s, and India was going through really financial problem at that time. And so what happened is that they stopped taking out the water from the mines. So that is how they became, that they couldn't do anything. And then slowly the mine got filled up with water, and we can't do anything.
Sayan, you are a young PhD student. What attracted you to come and work in these trying circumstances, half a kilometer below the earth? What attracts you?
Well, science is all about thrill, passion, and exploration. This is coming underground, 555 meters underground. It's a huge experience. And as you asked Susnata Di that whether we can find dark matter at all, well, it might take years, but in that years, we will be trained. And our training will help us in carrying out this experiment for years to come. And this hardware experience, hands-on hardware experience will help us a lot.
So you're willing to spend a lifetime working in this underground laboratory away from the sun, hidden away deep underground?
Surely. I have no problem. And it actually excites me rather than making me afraid that I'm coming underground. And it has been a nice experience, and I hope it will be for my entire career to come.
Already scientists are saying that we should have something deeper. And you're a person who's just starting off his scientific career. Have you given a thought on what should be the deeper mines or deeper laboratories India should have? And now we are no longer short of that 12-15 crores which Dr. Naba Mondal was short of in the 80s and 90s.
Well, we have had talks. I mean, my professors have gone. We have had talks with our authorities. In the future, we will be thinking about going down at around 1 kilometer deep, and that would be a lot better site for us to work in, because again, as my professor said, that neons will decrease more. It is already decreasing a lot, around 1,000 times, but if we go down more, it will decrease a lot, so our background will reduce.
Most people of your age today want to earn in lakhs and want to join software jobs or become chartered accountants or become lawyers. What attracts you to become a scientist?
For that, I tell you that I decided to study physics back in class 9.
Wow.
That excited because I credit that to my teachers back then. They made the subject too interesting for me, and it's actually science has always been the thrust to know the unknown. So if I can contribute to know the unknown, even a little bit towards science, then it would be a huge thing for me.
Knowing the unknown brings me to something which is an unknown in India, which only you know. See, we wanted to create that India Based Neutrino Observatory, which is kind of hanging fire. What is the state of it, that 1.2 kilometer deep underground laboratory where you wanted to set up a gigantic experiment?
In fact, it is really frustrating to even think about, the way it has been stalled year after year, and by falsehood and spreading wrong informations and scaring the peoples. And for example, things like that the neutrinos will come from United States and they're dangerous. When you said that we are always soured through by neutrinos, they will say that, those neutrinos that is created in the nature, they are good, but the neutrinos that will be coming in from the accelerator in the US are bad neutrinos. This type of falsehood has been spread, and as a result, there is a scare among the local people, and though they were supporting us at the beginning, they became scared. Actually, later on, when we went to them, they told us, we don't know who is telling us truth, but since we don't know, we are confused. You better not be there. And we have got the environment clearance, not only for this site, even for an earlier site, and we are ready in 2009 to start this experiment. Then we are asked to move for another site from Pusep, We went to Body Waste Hill, did everything again, all the environment clearances, everything is done. And when we are just about to start our construction, came there was politicians who went to make a PIL, or there was activists who went to the Green Tribunal, and we are stalled. I think we have to take a collective decision in the country whether we should make a progress or not. People say that, why should we do such science? We could spend money for primary school. Look at this one. We have such a huge country, such a huge young population who are hungry to know more. And why should we deprive them? Should we not have such experiments, some number of those in the country, when India is going to take place? India claims to be one of the developed countries in the world. We do not have even such experiment in the country. And this is really actually, I am at this age very sad that we are not been able to make INO success yet.
What could be done to bring INO to fruition? Is there something which the citizens of India can do?
Yes, I think they should sit with us. They should really look at the argument that we are giving, that it is nothing, it is just a simple experiment. It is an observatory, first of all. It is not even creating anything. It is only, the neutrinos are there, and we are only observing them, just like you make a telescope to observe the sun, observe the stars and galaxies. Same way, with our observatory underground, we will be observing the neutrinos that is created by nature. And this will give us information. Our young scientists will be able to work. We will be building cutting-edge technologies. And this is hands-on. All will be done in the country. This is Make in India. It can be done through such experiment if we do this experiment in the country.
See, there was problems with the Kudankulam nuclear plant. The Prime Minister stepped in. The Department of Atomic Energy stepped in. The Supreme Court heard the case on a fast track. Why is it that the scientists are unable to get that kind of support?
I don't know. I think actually we got, at least up to the financial sanction of the project is concerned, we got full support from the Department of Atomic Energy, from the Government of India, from MOEF and so on. Everybody gave us the clearances or the fund that we needed. However, when it gets stalled, we really didn't get that much support from, for example, the Tamil Nadu state government. We tried to convince the state government that give us the clearances. In fact, what it was stuck with only one simple clearance, the Pollution Control Board clearance, which is a simple clearance. And because we didn't get that clearance, the Madurai branch of the Madras High Court didn't allow us to proceed. And we needed that clearances to start. So we don't know, how we can do anything better to convince them. But I think through you, through media, through our public outreach program, we want to appeal again to public, to government, to everybody, just please give us this kind of science project. It is important for the future of the country.
See, people say neutrons and neutrinos are very close to each other. Why did scientists name them? Because people are afraid of neutrons, and you name them so close as neutrinos, and then you're blaming the public for being afraid. Why do you name them so close to each other?
I'll tell you the story. It was originally, when it was proposed, the name was neutron, not even neutrino. And this was when, originally it was proposed by De Pauli. But then Fermi, when he was, few years later, by the time real neutron, which is inside the nucleus, has been discovered. So then he said, the neutron is already there, but this is a little neutral particle. So it is neutrino. So Fermi gave the name neutrino. And, we had nothing to do with that. But, why should neutron get mixed up with neutrino? It is actually, so that tells you, brings back this question that maybe we are not able to propagate the message of science to common people in a big way. And we have.
Why don't you just change the name, give it an Indian name?
Well, it's not an Indian particle. A particle is for the whole universe. And why should we have a separate name?
Why should we have a separate name is what Dr. Naba Mondal says for neutrino. One person on Facebook had asked me a question. Why are we spending so much money on this underground laboratory? That's something which Dr. Naba also referred to. So how much have we spent on this? How many crores have you sunk 555 meters below the earth?
Well, in any science activities or any such activities, we need some amount of fund. But more than that, what we try to do is we try to utilize as much of our resources as possible, and precisely that is what we have done for this particular laboratory. This laboratory at the 555 meter level, we have spent some amount of money for the electrification of the lab, because it was.
So how much money have you spent?
So far, we have spent about 20 lakhs of rupees.
You must be joking, sir. 20 lakhs is chicken feed. Even flyovers cost a lot more. To set up a 555 meter below the earth laboratory, 20 lakhs? You are kidding me. Come on.
Well, as I said, that we have done this electrification of the site and some civil work which is required for isolating the room and then reducing the radon emanation from the surfaces, and that has cost some amount of money. And for the equipments, for the experiments that we are doing, you should be assured that we have used only the equipments that has been existing in that we are using in different experiments. We just pulled those resources together and started the initial set of experiments. Of course, we will require some money, particularly for the dark matter experiment. As you know, that it requires a large mass of detectors. Detector active mass should be large, and then it will require also a cryogenic setup. So they will cost some amount of money, but certainly it is not multiple tens of crores or hundreds of crores. It may be a few crores of rupees that will be required for that experiment to start with.
So to set up a laboratory like this, 555 meters below the earth, such a cool place, which is so very nice, which is so very interesting, where no journalist till now has ever come down. I bring you the story of excitement from the heart of Indian science. Now, will we find dark matter here? It's a question which will be answered when a paper is published from here. But till then, I think the country needs to be excited about setting up another laboratory in the 21st century, which is more than half a kilometer below the earth. If I may add, what does that mean? If 7 Qutub Minars were to be stacked up one above the other, that is the level under which I am below just now. A cool place in Jadugoda, in Jharkhand, where India has set up its dark matter search laboratory. And it doesn't end with this. The possibilities are immense. One can search for things and matter of different kinds. And the possibilities of doing experiments which are unique are many, many, and many. So from this underground laboratory in Jadugoda, Jharkhand, which is 555 meters below the earth, with camera person G.D. Shankar, in Jharkhand, Pallava Bagla for NDTV.